Hello everyone, this is Nehmat. Today we are going to look at phase diagram relationships in soil. This is given in chapter 2 of the book that you're following. So let's get started. So, what is this three-phase system of soil that we're talking about? This soil can be divided into three mediums. The first one we can call as solids, the second is liquids, and the third is gases. The solids that define the soil can be either organic or inorganic. The liquid in soils is mostly water, and the gas is air, as we all know. The organic solids are the plant and animal residue that is left after decomposition. The inorganic component of solids is the mineral component, and these come in different shapes and sizes. The liquid component of soil is mostly water, and these liquids and gases occupy what are known as voids, which are left in water. So if we imagine grains of soil, like if we see these are some grains of soil, there's always some space which is left between these grains of soil, and these are called as voids. So if you look at this void, this can either be occupied by either air or water. If the void is completely filled with water, we call it saturated. And if it's completely empty, I mean there's no water, then the soil is called dry. So now, what is this three-phase diagram that we're looking at? So imagine soil to be divided in three components. We have the solids represented by an S, we have the water which is represented by W, and air represented by an A. And there are these two sides of a phase diagram. The left side we usually call as the volume side, B, and the right side is called the weight side, which is represented by W. So the volume side, in the volume side we have these subscripts A for air, W for water, and S for solids. So we have VA, VW, and VS. And similarly on the weight side we have the weight of air, the weight of water, and weight of solids, right? So this is the general three-phase diagram of soil. Okay, so it's just we have these three components of soil: air, water, and solid. We're just like defining separately the portions represented by these three components. If for some reason one of the components is missing, let's say either air is missing or water are missing, then it becomes a two-phase system. Then it's like either solids and water and solids and air. So just as we said, if it's just solids and water, then we can say that it's saturated soil. And if it's only solids and air, then it is dry soil. Okay, so moving forward, if we look at this three-phase diagram again, we have air, water, and solids. We already discussed that this air and water, these are called voids, right? Because these fill up the spaces between the solid particles. So the volume of air and the volume of water is also called volume of voids. So we can say, in other words, the volume of voids is the sum of volume of air and volume of solids. And the weight of air is usually neglected in our calculations. It's taken as 0. So the weight of soil is just the sum of the weight of solids and the weight of water. But the volume is the sum of all three components. So if we would like to write that out, we can say volume equals to volume of air plus volume of water plus volume of solids. This is the total volume which we are defining here. And then we have the total weight of soil, which should be the sum of these three components. This should be weight of air plus weight of water plus weight of soil. And since we neglect the weight of air to be 0, this is just the weight of water plus the weight of solids. Okay. Now, important ratios and definitions. So we have a few important relations that we need to consider and hopefully memorize. So the first one which we are looking at is called the void ratio. So what is void ratio? This is represented by the symbol E. So if we look at the phase diagram, we have air, water and solids. This is volume of air, volume of water, volume of solids, weight of air, weight of water, weight of solids. So as we know, this is the volume of voids. So void ratio is defined as ratio of volume of voids to the volume of solids. Okay, so what should be the mathematical formula? So E equals to volume of voids, which is VV, and the volume of solids, which is Vs. This is a very important relation which we'll be using many times after this. So this is the void ratio. The next one which we are looking at is water content. So water content is represented by a small w. So what is water content? Again, if we have the three-phase diagram, we have the air, water and solids. It's usually concerned with the weight, so we're not looking at the volume side right now. We just focus on the weight side. So we have the weight of water and the weight of solids. So this water content is just the ratio of this weight of water and the weight of solids. So water content is ratio of weight of water to the weight of solids. In other words, mathematically, small w is WW over WS. Again, a very important relation which we should try to memorize. Then we have the porosity. So what is porosity? Again, we look at the three-phase diagram. This is represented by small n. So if we look at the three-phase diagram again, air, water and solids, this has to do with the volume. So volume and weight. Okay, so volume of air, volume of water, volume of solids, volume of voids and total volume V. So what's porosity? Porosity is the ratio of volume of voids to the total volume. So N equals to VV over V. So it's important to note here that there is this void ratio E and this porosity N. These two are different in terms of the denominator that we are using. E is VV over Vs, whereas N is VV over the total volume. We see the denominator is different in both cases. So in soil mechanics, usually we use the void ratio more because the denominator Vs remains constant. Uh, in maybe if you are moving the soil due to compaction, or the soil is getting dilated or contracted, this Vs usually remains constant, so it's a better thing to use. Whereas the total volume can increase or decrease depending on whether we are inducing air inside the soil or removing air from the soil. So yeah, so these three relations, the water content, the void ratio, and the porosity, these are very important, and we should try to memorize at least these three relations initially.